Thank you so much, everybody, and welcome to the live stream. My name is Tilda. I use they, them pronouns. I am a senior developer advocate for Haystack. And today I'm going to kind of be your MC. We have two awesome speakers, Carter and Tuana. They're each going to give a talk. And afterwards, if you want to put your questions in chat or the Q&A widget, I'll kind of be monitoring them, and we'll have a little Q&A session afterwards. And other than that, let's dive right in. Carter is joining us from Seattle, where he is the head VP of Developer Relations at DataStax. Thanks,
VP.
Carter. Over to you.
What's a VP?
I
I work in developer relations at DataStax. I'm really happy to do so. Love serving developers. Let's not worry about titles. We're all friends here. I'm going to go ahead and share my screen, and I'm going to kick off this talk. So let's see. All right. So, all right. I'm really excited to be here to talk to you all about what Taylor Swift has to do with the democratization of AI. But first, a little bit more of an introduction to me. My name is Carter. I use he, him pronouns. I serve developers at DataStax. I'm new. I feel like I've become this Gen AI nerd, but this is really new to me. And for folks who are watching the stream, like it might be new to you. I mean, it's new to all of us on some level because this has really not been around in a mainstream way for longer than about 18 months. But I joined DataStax a little over 3 months ago, and prior to that, I had never touched OpenAI or anything related to AI. I was just sort of what you might think of as sort of a standard full stack JavaScript developer. So, very fluent in JavaScript, React, Node.js, frameworks like Next. That was sort of the world that I lived in. So this is all relatively new to me, but I'm really loving it. I am here in Seattle, Washington. When I'm not data staxing, I'm the organizer of the Seattle JavaScript meetup. And I'm also the organizer of the Cascadia JS conference, which is actually coming up later in June. So if you love the web, love JavaScript, and you want an excuse to come to Seattle, come check us out. As I mentioned, full stack JavaScript developer. I'm a husband, a father of 2 awesome kids, and a dog dad. So he's not here right now, but my Labradoodle Otto is roaming around the house, and you can find me on the socials in general at CRTR0. So I want to talk to you about how AI has become democratized, but I want to set it up by spending a little bit of time talking about how technology continues to get democratized over and over and over again in ways that are like incredibly positive and wonderful. So I'm going to start this story in maybe a strange place. I'm going to talk about the Super Bowl back in 2002. So I was at a college for a couple years. I was working at this company, and we were a small company in Washington, D.C., and we won a contract to power this unbelievably cool, innovative experience at the time. So if you were watching this game, and if you were watching this game in the United States, at halftime, the broadcast actually prompted you to vote for who you thought the MVP of this Super Bowl was. And the way that people were asked to vote for their choice was via SMS. And look, we take it for granted now for reasons that I'll talk about in a second. But at the time, this had never been done before. And this had never been done at this scale. There are probably 100 million people that watch the Super Bowl just in the United States. And they were all being asked to send a text message to a phone number to vote for either Tom Brady or Kurt Warner or whoever they thought was the MVP. And we, a company of maybe 20 or 30 people, we were building this application and had to make sure that it worked. So now I needed to understand that back then, what this meant that we had a server, a really beefy server that was literally in a closet in our office. And that server was connected to the internet, and we had a connection from that server to to a company that basically bridged our server onto the network that is used by telecommunication companies to route SMSs. So every time someone sent an SMS to this phone number, that company would make an HTTP request to our server and our application. And I'm not kidding when I say that, like, me and all the other engineers at this company were just absolutely, we couldn't even enjoy the game because we were sweating bullets. We're staring at the server. We're waiting for it to erupt into fire. We're like tailing our logs. Like the amount of stress that was involved was astronomical because it could not fail. Like if it failed, there wasn't going to be like another Super Bowl the next day. So this is what it felt like back in 2002. Moving forward to 2012, so 10 years later, this is a photo, a couple photos that I took at a wonderful conference called JSConf. It's just one of the best conferences for web and JavaScript developers that has ever existed. They're not operating anymore right now, but this is from 2012. And what are we looking at? We're looking at my colleague at the time, John Gottfried, doing a demo of a product or a platform called Twilio. Now, I'm hoping that most of you know what Twilio is. If it isn't, just go to twilio.com. But 10 years after me and my fellow colleagues were like staring at a server, like praying for it not to erupt into fire, John Gottfried was able to get up on stage and quite literally build an interactive Pac-Man video game that you could play using your phone. You could call a phone number and then you could hit certain numbers on your keypad to make the Pac-Man move up, down, left, or right. And John didn't have to work. John wasn't worried at all that that his code was going to fail or that his web server was going to explode, because Twilio had taken all of the hard work of making it possible to interact with the telecommunications systems, and just they democratized it and made it easy for any developer, any web developer, to do this effortlessly, at scale, and without any concern that things weren't going to work. So it's just kind of amazing to see this process happen over and over and over again, and we keep seeing it happen, right? Me and my colleagues, actually owning and operating servers in closets, and like we now live in a world of AWS and the cloud, right? AWS and other providers have democratized the ability to run and maintain servers. Like the average developer doesn't have to worry about patching their Linux or keeping it up. Things like Google Maps. I mean, like we take it for granted now, right? That like, oh yeah, like anybody can just sort of like have like real-time mapping capabilities baked into their applications that can auto-detect like where we take this stuff for granted, but 10, 20 years ago, it would have been almost science fiction to think that developers could have these kinds of capabilities built into their web applications or their mobile applications. I can keep going, like same with Stripe, right? Like I promise you, 20 years ago, the ability for someone building a website to process a credit card was awful and hard and fraught with all sorts of edge cases and things that weren't going to work. And like now it's like you paste in a lot of code and you're done. And things like Alexa, Alexa has made voice powered applications and interactions like as easy as writing some XML. So we see this pattern happening over and over and over again. And that brings me to, AI, right? So what I'm showing you right now is this was back in 2006. Netflix issued $1 million challenge, right? They challenged the whole world and the whole internet. Hey, we'll pay $1 million to someone who can build a better recommendation engine, because Netflix understood that their ability to sort of be successful required them to help their users consume more videos and to make better recommendations about what they should watch. But back in this time frame, back in the early, mid, late 2000s, the ability for a technology company to like build and ship like really great recommendation engines was the domain of big tech, right? Like, yeah, sure. If you're Netflix, if you're Amazon, if you're Google, like whatever, like if you're a huge tech company with a vast, engineering workforce and tons of brain power, yeah, you can probably build a pretty cool recommendation engine. But if you're, one developer or two or three or a startup or a small shop, forget about it. Like this is like completely like out of your domain. And this is back in 2006. And then you fast forward to today. So once again, like I'm relatively new to the AI space. I I honestly spend most of my free time. I mean, I don't have much free time, but I spend most of my time like learning about all the tools that like have been created and are currently being created that are democratizing AI and democratizing all of these different use cases for developers. This diagram I'm showing you, I'm sure it will be, it's already out of date. Things are moving super, super fast. But all of the things, what's happening in AI is that people are discovering more and more of like the best use cases for AI. And then engineers are discovering like the best patterns for how to build applications that satisfy those use cases. And then those patterns are being turned into products like Haystack. And this is happening at this super rapid pace. So on the downside, things are pretty chaotic. Things are changing all the time. But on the upside, these tools exist. They're getting better and better and better, and they're enabling developers to build things that was basically just the domain of big tech before. So that kind of brings us to maybe my personal story about Taylor Swift and what that has to do with AI. So I'm new to DataStax. Part of what's awesome about being in developer relations, and by the way, if anyone is curious or interested in developer relations as a job or as a career, like please come find me on Twitter. I'll talk to you about it. Part of the fun thing is being creative, right? Like figuring out like how do you connect the dots between, I don't know, a vector database or some kind of technology and things that people can relate to and have fun with. So we were sitting around at work trying to come up with like fun ideas for things that we could build that could showcase the power of AI. And I just blurted out like, hey, like, why don't we build some kind of Taylor Swift chatbot? Where I don't, for folks, I'm sorry if I'm dating myself, but before social media, there used to be these fantastic websites like GeoCities and LiveJournal that people would use to create fan sites. So you'd have these like really amazing fan sites dedicated to bands, artists, maybe sports heroes, like whatever. And I just kind of imagined like, what if we could take the idea of a Taylor Swift fan site that just loves Taylor Swift and knows everything about her and turn it into a chatbot, right? What if we could make that an interactive experience? So I just kind of threw that out there, like, yeah, we should build that. That'd be really fun. And then someone on my team said, like, oh my God, that's a brilliant idea. And guess what? Her birthday is coming up in a week. We should do that right now. And I'm not gonna lie, like I kind of freaked out because like, hey, I was just trying to come up with a fun idea. I was not expecting that I was going to be expected to deliver this in a week, right? So at first, I'm going into a full-blown panic, like how on earth are we going to build this and ship this in a week? But then as I start to dig into all of the tools that are available to me, and it wasn't just me that worked on this, but there was a small team at DataStax that built this. When we started to look into like all the tools that were available to us, it started to feel more and more possible. And that's where we ended up. In roughly a week, we got there. Like we were able to ship SwiftieGPT on her birthday and sort of put it out there on the public internet for people to use. So that was an absolutely amazing experience. So what I want to I want to kind of transition to how we built it, and I want to dive into the code behind this, right? So for those of you, I'm sorry, like it's weird when I can't see people, but usually this is where I say like, hey, raise your hand if you've heard of retrieval augmented generation. So for those of you who don't know what retrieval augmented generation is, it's a way of building these AI applications that leverage all of the smarts of LLMs, but augment it in ways that give the LLM information that it doesn't have. So what I'm going to do for the remainder of my talk is sort of walk you through the journey of building the SwiftieGPT and hopefully like help sort of explain, like hopefully help you understand like how RAG actually works and why it's so useful in this case. So in order to get our journey started, I'm going to start on the generation side of things. So let's go ahead and exit the slide and go into my code. All right, so I'm going to fire up. So this is Visual Studio Code. And by the way, the only important link that I'm going to share at the end of my talk is a link to the GitHub repo that has all this code. So don't worry about keeping up with what I'm doing. This stuff is all open source. It's all on GitHub, so don't worry about it. But what I want to do is I want to go ahead and get my server running. All right. So great. So now I've got my server running, and I'm going to go up to the next JS code that is going to power the actual user experience. And right now, this actually is the full code that you'd find on GitHub. But what I'm going to do is I'm actually going to cripple it. I'm going to kind of make it dumb, because I want to show you what generation without the augmentation and without the retrieval looks like. So how are we going to do that? Well, down here, I'm going to skip past all of this Astra DB stuff. Actually, I'm going to minimize this window right here, and I'm going to go down to this template, and I'm going to go down all the way down to the call that we make to OpenAI. So this code right here, this is where we're calling OpenAI, and we're passing in both a template and some messages. Here, just above it, is where we define our template. So temporarily, I'm going to make our template blank. And I hope that you'll see why in just a second. So I'm going to set the content to empty string. I'm going to comment all this out. And all right. And I think we're good. So let me go ahead and give that a run. Our next app should hopefully rebuild after I save that file. In fact, just to be sure, I'm going to go ahead and rerun the dev server. And now I'm going to switch over to my browser. Let me move this Zoom stuff out of the way. Go to where I want to go. All right. So I'm going to go to my local host, and I'm going to load this, and hopefully this works. Okay, awesome. So we've got our UI. So let's ask it a question. What is Taylor Swift, or I'm sorry, let's say who is Taylor Swift's boyfriend? All right, let's see what the answer is. Okay. So for the Swifties that are in the audience, Joe Alwyn is absolutely the wrong answer. And I did this on purpose, because what you are seeing right now, this is just the exact information that you would get if you asked ChatGPT who Taylor Swift's boyfriend is. And why is that? Well, ChatGPT and all LLMs are trained on vast amounts of public data, right? They're just like Google. They go around the public internet, they're scraping all of these websites, and they use all of this content to sort of build this knowledge graph of facts. The problem is that ChatGPT and certain models stopped scraping the internet at a certain point in time, which means that they don't have any information beyond that. Let me ask another different question. Who are you? Yeah, it's just I'm OpenAI's language model. I'm GPT-3, right? So this is, not only does it not know who Taylor Swift's boyfriend is, it is definitely not acting like a Taylor Swift superfan. So this is, I hope this is a sort of a clear sort of picture of what generation looks like. So, okay, what does it mean? What does augmented generation mean? Oh, I'm so glad you asked. Let's go back to the code and augment our prompt to see if we can improve our results. So that's exactly what we're going to do. I'm going to go back to here where I commented out this prompt. And we are now we're going to augment this prompt with instructions for OpenAI that tell it how it should behave, right? And this is incredibly, incredibly important information. So we're going to tell OpenAI, you are an AI assistant who is a Taylor Swift superfan. Use the context below to augment what you know about Taylor Swift. And we provide other instructions. You know, if the context doesn't include this information, you need to answer based on your existing knowledge. Just say you don't know. This is basically prompt engineering. If you've ever heard about prompt engineering, this is a simplified version of what that is, where we're providing very, very clear instructions to the LLM, like how we want it to behave. Another quick thing I'm going to do is I'm going to set doc context equal to empty string. You'll sort of see why in a minute. But let's go ahead and save this and go back to our code and see how it changes its behavior. So I'm going to go ahead and reload this app, and I'm going to ask the same question. Who is Taylor Swift's boyfriend? All right, interesting. So it doesn't know who Taylor Swift's boyfriend is, but the answer has somewhat changed. Let's ask another question. Who are you? Ah, nice. So it's an AI assistant who's a massive Taylor Swift fan. And it tells us exactly what kind of information it's allowed to provide about her. So this is an example of augmentation, where we have augmented what ChatGPT returns by doing some prompt engineering, but we still haven't succeeded, right? Like we haven't gotten it to be the super fan. And the reason we haven't gotten it to be the super fan is that there's too much information about Taylor Swift that it doesn't know. So that leads us to the final step, the retrieval portion. And this is where Haystack and excuse me, where Haystack and Astra DB come in. So I'm going to go back to my code editor, and I'm actually going to close my server. I'm going to go down here to some scripts that are written in Python. So I won't go into these scripts in tremendous detail, but the simplest thing to explain is that they use Haystack to scrape a bunch of websites that contain information about Taylor Swift. And then we run that through a Haystack pipeline. What is a Haystack pipeline? I won't go into too much detail, but visualize a pipeline. Haystack makes it incredibly easy to build these pipelines and to run data through the pipelines where at different stages, different things are happening. So here we're initializing something called a link content fetcher. That is going to fetch the HTML content from the links that I provided. The next thing we're going to have is something called a converter. This is going to convert that HTML content into an actual Haystack document. Next, we're going to initialize a document splitter. In this case, we're going to tell it, hey, please split these potentially long documents by word. Specifically, split them into chunks of 150 words and make sure that there's 50 words of overlap in between the chunks. This is necessary in order to provide better context to the LLM to help it answer questions. We're going to specify an open source model that we're going to use to create the embeddings for this content. So this is where something like Astra DB comes in. So once again, I work at DataStax. DataStax has a product called Astra DB that is a vector database. It's a vector and NoSQL database. Developers can sign up for Astra DB absolutely for free. So just go to datastax.com, click try for free. You can sign up, no credit card needed. You can get started right out of the bat. So for each of the chunks that we're getting back from the Haystack pipeline, we're going to calculate a vector embedding for that chunk. And we're going to store all of those chunks in our vector database, and specifically in a collection called SwiftieGPT. So I'm going to go ahead and run this script actually, and I should have done that earlier because the scripts take a little bit of time to run. Oops. Let's see what's going on here. See. You try the RSS script. Statement out of a module. All right. This is the joy of live coding. So let's see. Sorry. Let me try to double check this. Like my version of Python, that looks good. All right. Well, let's not worry about this. Let's talk through what would have happened. So I'm going to go ahead and show you my Astra DB. So here, this is the database that we created for SwiftieGPT and Haystack. So when the data gets loaded, right, all of those chunks would get populated right here, and we'd be able to access them in our Data Explorer. So next, after all of that information gets loaded, we now have all of the information that we need to create better context for SwiftieGPT. Let me try one more time to figure out what might be happening
It looked
here.
like you were running a Python script with Node. That might be the issue.
Oh man, thank you so much, Tuana. Did I say that I was a full stack JavaScript developer? First and foremost, that is entirely true. So awesome. Thank you so much. That answers the question. The script works. I just had to use Python. All right. So while the script is running, by the way, thanks so much for chiming in there. While the script is running, we're going to store all of this stuff into Astra DB. One thing that's awesome is that if we go back to the UI, we actually don't have a collection created yet. And one of the things that's great about Haystack is that it'll create the collection for me, and the collection is going to be called SwiftiePedia. So yeah, so this process is happening right now. All of this data is getting sent into Astra DB. If we just wait a second, it actually runs pretty fast. If we wait a second, we're going to see how many documents were created from all of these websites that I defined. So let's just give it a sec. In fact, I could probably switch over here and just reload the page, and we should see data coming in. Yes, awesome. All right. So we have a SwiftiePedia collection that's been created. I'm going to zoom in on that. Oh, I'm so happy. We have 325 records that have been created. If I go back to my terminal, we can see that it's done. All right. Thank you so much, Tuana. Another thing I want to share with you all, which I'm incredibly excited about, one of the challenges of building these RAG-based AI applications is just getting clean data. What you see right here is data being scraped from web pages. And one thing that I thought would be really useful would be scraping content from RSS feeds. So that is not something that Haystack currently natively supports, but luckily all of Haystack is open source, and I was able to look at the converter. So up here, remember, I'm using a converter called HTML to document. That is a converter. I was able to look at the source code for the HTML to document converter and create my own converter called RSS to document. So it took me maybe 30 minutes to make this converter. So now we can go ahead and run my load RSS script, and we can load the content from one particular RSS feed that I found and also get that into my database. And one of the things that's just really awesome and you can see now we went from 325 documents in my database up to 334. So now I've loaded up my database with all of this information about Taylor Swift. So now let's make the chatbot smart. So I'm going to restart my server, npm run dev, and I'm going to go back to my Next.js app. And I'm going to add some logging because I want us all to sort of see what's happening. So I'm going to scroll back up here, and I hope this is big enough for you all to read. At the very top of the file, we're going to get some environment variables that we need to connect to OpenAI, but also connect to Astra DB. So these are all stored in an environment variable. It's really easy to initialize our clients to both of these things. The next thing we're going to do is we're going to get the message, the last message, the most recent message that the user entered into the chat. And here we're going to use the exact same model that we used to create all of the vector embeddings for the content that we scraped. We're going to use the exact same model to create a vector for the question that you have asked, right? This is super important. In fact, it's so important that I'm going to console.log it. So console.log JSON.stringify vector. Okay, so this is going to output to the log when we ask the question. The next thing I want to output to the log is this thing called doc context, because this is going to hopefully paint a picture for you about why the LLM is able to be smarter to answer the question. And let's go down and just remember, let's review this prompt that we're using. These are the instructions that we gave it, but here, this content is going to get injected into the call to the LLM. This is how the LLM is going to be smart. So, okay, awesome. So I'm going to go ahead and save this. I'm going to go back to my local host. I'm going to go ahead and reload it. And here's the moment of truth. I really, if this goes wrong, then I'm going to be so sad. But I'm going to ask SwiftieGPT, who is Taylor Swift's boyfriend? And I really, really hope it gives me the right answer. Yes! Awesome. That is the right answer. As of July 2023, Taylor Swift's boyfriend is Travis Kelce. So look, awesome. It gave us the right answer, but I want to show you exactly how and why. It gave us the right answer because going back to my terminal, now I'm going to kind of show you the terminal. I'm going to scroll back up here, and you're going to see this really huge, ugly number. This is a vector. And I'm going to copy and paste this entire vector. Now, remember, what does this vector represent? This vector represents the question that I asked. So going back to my browser, I asked, who is Taylor Swift's boyfriend, question mark. That question got converted into a vector. I can now go back to, as an example, I can go back to Astra DB. I can go back to the Data Explorer. I can actually paste this vector into the Data Explorer, and I can click apply. Remember, I've got 325 records in this collection, but now I've actually asked it to do a vector search. So it has resorted all of the records based on other records that have vectors that are close to the vector that I provided. Remember, vectors are like, you can visualize them as like points in n-dimensional space. So if we have a database of 325 vectors, just think of n-dimensional space with all these points in it. If I give it a point, it's going to return all the points that are closest to the point that I gave it. So if I actually look at just the top document, what does it say? Well, it says, yes, now we're in our current Taylor dating era. In July 2023, blah, 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 Arrowhead Stadium, Kansas City, Travis Kelce, right? So like our question yielded this document in addition to other documents, which effectively answered the question that we asked. So that's the power of vector search. If we go back to our code, we actually asked Astra DB not to return the top document, but here under limit 10, we asked it to return the top 10 documents. We then took all 10 of those documents and we concatenated them together into this word salad that you see here in the terminal. And you might think of it like, hey, this is just gibberish. Like this doesn't make any sense. But that's the magic of LLMs. Like they can take this they can take this word salad in addition to the question that you asked, and they can actually figure out how to mine it and pull out the correct answer. And the answers are better and better and better based on how well you do in your prompt engineering and how well you do in providing additional and relevant context to the LLM. So I'm super happy that that worked. All right, so wrapping up this presentation, hopefully that kind of gives you the simplest and easiest to understand explanation of like what retrieval augmented generation is and how it works. You're on a live stream, no need to take pictures of this QR code. We will share it with all of you, all of the links to Astra DB, to the GitHub repo where all this code lives. We'll share it after the stream. But other than that, thank you so much for coming to the talk. Thanks for bearing with me as we sort of debugged live what was happening. And I'm happy to take any questions that folks have. Thanks so much.
Thank you so much, Carter. That was really educational, like really just breaking down RAG every step of the way. And then, yeah, like showing us what happens when you don't have the retrieval step and have what kind of different answers you get. So we have a couple of different questions from the audience. Anonymous attendee says, I missed the step where the converted data is loaded as vectors to Astra DB. Was there an OpenAI embedding step in the pipeline?
Yeah, totally. Should I share my screen? Let's do that. Let's kind of keep the screen shared, and you can just and you can kind of feed the questions to me. But yeah, absolutely. So here, I'm sorry. No, there wasn't. That's a really fantastic question. So people get this confused all the time. We are actually only using OpenAI to construct the natural language responses. So here, this is like the hosted version. You know, how did Taylor Swift become Times Person of the Year? We are only using OpenAI to construct this natural language response. You can also use OpenAI to calculate and compute embeddings, but that's not what we're doing. There's a lot of reasons that we're not doing that. One, it costs money. It costs money to use OpenAI to calculate and compute embeddings. So what we're doing is we're using an open source, completely free embedding model that I got off of Hugging Face. Hugging Face is a website that sort of hosts and helps people find models. So yeah, so this, and you can actually go up here. Let's see, where is this coming from? Sorry, embedders. Yeah, right here. So this is just like pip install. Like I'm bringing in this sentence transformer, this is where I'm initializing it. And this is very important. It doesn't matter. It doesn't matter if it's OpenAI or open source. Whatever model you use to create the embeddings that you insert into your vector database, it has to be the same model that you use on the retrieval side when you're building the RAG application. So if I scroll up here, this, even though it's different languages, right? Like the Python, the ingestion was all happening in Python, but here in JavaScript or in Node, we're still using the exact same model. And then the OpenAI is only used for the chat completion step. So yeah, I hope that explains it.
Awesome, thanks. We have time for one more question. Kieran asked,
Okay.
will Astra DB update the changes incrementally?
No. That is so Astra DB will actually, I feel like it's a kind of a great question for Haystack, right? So like what I showed you was a script that I ran to ingest all of that data, but like I'm manually running this script. Now I know that Haystack has this fantastic model that lets you be specific about like whether you want to overwrite things or like how you want to handle duplicates. So in my case, like I'm running the script manually. In the real world, I could set up some kind of cron job, or I could set up some kind of process that reruns this code at any cadence that I want. And I think Haystack has lots of knobs and dials that you can use to define the behavior, like when that ingestion, when those pipelines get run. I don't know if the Haystack team wants to kind of chime in on any sort of additional information there.
That's why I turned my camera on, but you basically explained it. So the idea is, I think you just ran this pipeline once, but pipelines are just this entity, and you've basically described how you want embeddings to be created. And you can set it up so that anytime there's any change in your database, that pipeline reruns. And you can also make sure that if there's data that hasn't changed, those do not get duplicated or repeated in your document store. So you already answered it perfectly. Yeah.
Awesome. Yeah. And I will say this, look, there are a lot of tools that people can use for this. I've used most of them. And there's some questions in the chat about other options. I really enjoyed using Haystack. Like one of the things, as you're sort of comparing different tools, right? Like once again, like the data needs to be as clean as possible. Like if you're scraping web pages, like you do not want a bunch of, script tags or CS style tags ending up like in the actual text of what you're trying to vectorize, because that's completely irrelevant for the LLM. I think Haystack I think their modules for scraping these web pages and kind of getting clean text out of them and converting them into documents was awesome. And there have been multiple versions of SwiftieGPT, but the version that I'm going to share with you, that we're going to share the link out, is a fork of the original version, and the fork uses Haystack. And personally, like I've just found that like the actual responses from the LLM have been a lot better, and I think that has to do with how clean and organized the data is from Haystack.
Thank you. No, it is my duty as the MC to inform everybody that we really appreciate your questions, but we have to keep things moving along so we have enough time for 2 honest talk. But thank you again, Carter. That was educational and fun, and we really appreciate you taking the time to speak to all of us.
Thanks for having me. See y'all later. Thank you so much, Tuana. I really appreciate it. And Tildy, but I'm specifically helping me with the live debugging. Bye.